Welcome back to my YouTube channel Satya Evil. If you have not subscribed my channel, kindly subscribe my channel. Now we are moving to the second unit, mobile network layer. I am Satyaraj, assistant professor working in RMK College of Engineering and Technology. Let me proceed with the mobile network layer. Why we go for mobile network layer? So mobile network layer. So in nowadays we need extensions to the internet to support the mobility of the host. So for that, the mobile network layer takes a vital role. That is, we have in this unit we have introduction for the mobile IP. IP stands for Internet Protocol. So Internet Protocol packet delivery, and we are going to see agent discovery, tunneling and encapsulation, IP version 6 network layer in the internet, and session initiation protocol with respect to advanced version of the mobile IP, and then mobile ad hoc networks and the routing protocols. These two are the routing protocols, DSTV and DSR. So let me start with the introduction. So before going to the mobile IP, let me start with a subnet. What is a subnet? Subnet is a logical subdivision of the IP networks. So why we go for the subnet? So subnet is nothing but we have a IP address. We are splitting the IP address with respect to different subdivisions of the IP address by means of assigning the different IP value. So the IP value with respect to routing. So this routing makes very more efficient when you go for subnetting. So subnetting in sense we are performing routing in the network layer. So that is we are dividing the um, subnets with respect to transferring with respect to routers and assigning the destination address. For example, the destination address of the IP address starting from the source address 129.13.42.99. So if this system connected from a source system with respect to a source IP and destination address with respect to destination IP. So for that, I'm going to apply a prefix with respect to that. So the prefix is 129.13.42. So that incoming packets, so whatever incoming packets will be transmitted and forwarded. Okay, so the to the respected destination. So here consider the system to be a system which is having generating a source address. So it is just routed with respect to different system and consider this is to be the destination system with the destination address. So the packets are transmitted from source system to the destination system via different devices, wireless devices connected over here with respect to different mobile internet IP address. So if it is transmitted, so these are connected with respect to routing. So here the router cannot store all the informations in the specific computers. So for that what we need is we need internal lookup tables. So each and every time the internal lookup tables cannot be updated since the router cannot share all the address of all the computers. So the host needs a address which is said to be called topological current address. So where the system currently located. So that is said to be topological current address. So this is addressed by means of a protocol called DHCP. DHCP stands for Dynamic Host Configuration Protocol. So the Dynamic Host Configuration Protocol, what it does is it is able to find the that is when we are going for multipath routing, when it is difficult and impossible to find the mobile and host and search for new address. So for that we go for the new address. For that we go for domain name system. So DNS stands for domain name system. So here the same IP address with existing which are very difficult. So hence it is with emergency purpose to reachable purpose we go for the same IP address. When the same IP address is used, what happens is the domain name system is located with respect to the mobile. So if that does not work, if the mobile moves often. So when the mobile terminal or the device, when it is moving often, so when it is in mobile means when it is moving, so it is very difficult to track. So for that it is too expensive also. So and it is very difficult to update the quality of improve the quality of service and update the system quickly. So for that we go for the TCP sockets, which is in the TCP layer, TCP in the transport layer. So TCP transmission control protocol will be used here, and TCP also exhibits a severe problem since IP networks relay with respect to the IP address. So TCP also relates with the lowermost network layer to the transport layer. So TCP sockets consist of source IP address, source port, destination IP address, and destination port. right? So these are the things required in the TCP sockets. So why we go for the mobile IP? The motivation behind going for this mobile IP is that based on destination address network prefix, that is example 129.13.42, which determines a physical subnet. So I already explained that. So current change of physical subnet implies a change of IP address which has a topological current address. That is, it requires standard IP. So it modifies the changes in the routing tables. So each and every time the routing tables need to be updated. So this forms a difficult task, and we go for the specific routes to route the end system. So how to specifically route and corresponding data has to be sent to the end system by means of changing all routing table entries to forward packets to the right destination. So this requires number of mobile hosts and frequent changes in the location. Each and every time, since it is moving each and every time, we need to locate it. So this has a severe security problem. So to overcome this, we are going for changing the IP address. When we change the IP address, what happens? It automatically adjusts the host IP address depending on the current location, and also it determines the mobile system with respect to domain name source. So the domain name source equally updates with respect to time. Thank you. So now we go for the mobile of goal of mobile IP. So the goal of mobile IP, in sense, we can say that goal of mobile IP is that supporting end system mobility while maintaining scalability, efficiency, and compatibility in all aspects with existing applications and internet protocols. That means we are supporting the end system. So end system is located somewhere. When it is moving, so it is mobile while maintaining scalability, efficiency, compatibility in all aspects with the existing applications and internet protocols. So next is requirements for IPv4. So what are the requirements? Why it is needed? Since it is having a transparency in sense, when the system is moving, so when the system is moving, that means when it is mobile, so what happens is the effects of due to the effects of mobility, higher delay, it results in higher delay and lower bandwidth. So this is the constraint. So example, we go for the cost based routing. So example, cost based routing, with respect to the cost, it is updated, and video compression. So here in this point, we go for the transparency with respect to compression. So the point of connection to the fixed network that can be also changed. Then comes the compatibility. So compatibility in sense support of same layer with respect to two protocols such as internet protocol, and no changes to current end system and routers required. So mobile end systems can communicate with fixed systems, and it is also compatible. The security in sense, we can establish security to the advanced encryption standard, data encryption standard, or triple data encryption standard. So these are the encryption schemes which are mainly used for the security purpose. The efficiency and scalability. Efficiency in sense, we can make the system to be more efficient by little additional messages we are adding to the mobile system, which is required. So in sense, it has to be transmitted with respect to a radio frequency link, which is having a low bandwidth. So worldwide support has to be given. So since large number of mobile systems in the internet has to be transported, so scalability also plays into a vital role. So next is nothing but we have different terminologies to be learned. One is mobile node, home agent, foreign agent, care of address, and correspondent node. Before going to the mobile node is nothing but it is a node that can change the point of connection to the network without changing its IP address. Let me explain this first. basic terminologies and we go for the mobile node and foreign node. So first we go for the term called correspondent node. CN stands for correspondent node. Here one partner needed for the communication. At least one partner has to be there. And this works with respect to the mobile network. Either the node can be fixed node or mobile node. This is the requirement for the correspondent node. And home node is nothing but home network. Subnet of mobile network is nothing but a home network. So from the mobile network, we are having the subnet which is said to be the home network. Here no internet protocol support needed. And foreign network, in sense current subnet of mobile network visits the another network which is said to be the foreign network. And it doesn't have the home network. So care of address, COA stands for care of address. Here the current location of mobile node with respect to IP packet delivering also done. And when the mobile node moves with respect to this, we go for a concept called tunneling. So tunneling here, the way packet moves from one network to the another network is said to be tunneling. And we have another concept called encapsulation. So this we will be learning in detail. So what is encapsulation? Tunneling is a process where the data packets moves from one network to the another network and work via another network. And here encapsulation in sense wrapping up of a packet inside the another packet. So wrapping up of a packet from network layer from one packet inside the another packet. So that is said to be encapsulation. So we have two possibilities of doing the care of address. So one is the mobile foreign agent care of address, another one co-located care of address. So the foreign agent care of address is since foreign agent tunnels endpoint and many mobile network using common foreign address which shares a common care of address. So here it is nothing but the foreign network with respect to foreign address, it tunnels the endpoint. Tunnels means what? It makes a network packets to move from one data point to another network. With respect to many mobile nodes, when it is having, it will share a common foreign address. Okay, so which shares a common care of address, that is said to be foreign care of address. But here in the co-located care of address, the temporary IP address of the mobile network alone is known, and this is acquired with respect to dynamic host configuration protocol DHCP. Okay, so we go for the previous terminologies, that is mobile network, home agent, foreign agent, care of address, and correspondent node. Mobile node in sense we can say that mobile terminal with respect to a change of point of connection with respect to network without changing its IP address. IP address is not changed, fixed IP address. And home agent in sense system in the home network of the mobile network. Typically a router is said to be a home agent. So the registers the location of the mobile network, tunnels IP datagrams to the care of address. Foreign agent system in the foreign network of the mobile node, typically a router which will also forward the tunneled datagrams to the mobile network, typically which is also a default for router for the mobile network. And care of address already we have seen the address of the current endpoint for the mobile terminal at foreign agent or mobile node or mobile network. So actual location of the mobile network from IP point of view, and this is also can be chosen via the dynamic host configuration protocol. So for communication node, at least one communication partner need to be present in the network. So this is an example where the data is transmitted from the correspondent node through the internet, and this is transmitted with respect to physical home network from the mobile network through the home network. The home agent which will be sending the with respect to router, and the data will be transmitted via internet through the different mobile foreign agents, so through different routers, and this will be exchange communication with respect to the mobile end system. So each and every time the router will be able to send the current physical network for the mobile network. So this is a data transfer to the mobile system. So how the data is transferred? First, the sender sends the IP address of the mobile network with respect to the home agent, which intercepts the packets with respect to it sends the proxy address resolution protocol ARP, and then the tunneling process takes place. Tunneling means we all know that the data packets moves from one network to the another network, and from here to the home agent from CN to the home agent, it tunnels to the care of address. Here the foreign agent, what happens is foreign agent will receive the data packets through the encapsulation process. Already encapsulation I have explained, and the foreign agent forwards the packets to the mobile network. Hence the data is transmitted to the mobile system. So next is data transfer from the mobile system. So from the mobile system to the correspondent node. So how it is transferred? From the mobile network, it sends the IP address to the receiver as usual, and it forwards to the foreign agent, and then the foreign agent acts as a default router, and then it is received to the end system. So we have seen in the previous slide, that is data transfer from correspondent node to the mobile network, and here from the mobile network to the correspondent node, from the sender to receiver. So next is the overview. So this is the overview of data packets sent from the home network to the foreign network. So home network, it automatically sends with respect to the home address router. So which is data packets are transmitted via internet through the router of the foreign agent, which has the correspondent address, care of address, and then it was transmitted to the mobile network. So hence similarly we have the data connection we have seen in the previous scenarios, two scenarios. One is from foreign network to the router, and another one is to the correspondent node to the foreign network. So next is network integration. So network integration, in sense we have two things to be remembered. One is agent advertisement, and another one is agent solidization. So in the agent advertisement, what it will do means it will advertise with respect to the home agent and foreign mobile network, which will advertise with respect to the foreign agent through by sending the beacon packets. So how it will send the beacon packets? By means of sending the advertisements using special advertisement agencies. So using special advertisement message, it will send the information from home agent through the mobile network through the foreign agent. So this will be sent with respect to a packets formats called ICMP. ICMP stands for Internet Control Message Protocol. So this Internet Control Message Protocol, in sense it will transmit the data via the mobile node, and the mobile node, it will be automatically moving from one place to another place. So when mobile node moves from one place to another place with respect to the another set of router with respect to distance agent, that is the foreign agent. So the it is very difficult to calculate and find the exact location of the mobile network when it is moving from one mobile terminal to another mobile terminal. So the mobile network automatically listens to the messages and detects and check if it is whether the home agent or a home foreign network. So in case of network, so mobile network also reads a care of address from the foreign advertisement messages. And second one is nothing but solidization. So solidization, in sense it is not that much giving advertisement. So it is another packet format which is supported with respect to the mobile IP. So this is also used for transfer of information through the that is when the data transfer taken place with respect to no advertisements, or it is present with respect to inter arrival time. When the inter arrival time is very very high, what happens is mobile network has not received the care of address by other means, that is through DHCP. So what happens is mobile node will send agent call agent solitizations. These solitizations are what happens is it will be ensuring the solitization messages do not flood over the network, and hence it will be having three solitizations based on one with respect to time, that is with respect to seconds, and second one it enters with respect to new network, and third one dynamically wireless networks with moving mobile nodes. And probably these applications will be very much useful, and these solitization messages will not be too long, it will be very very short, right? So these are the agent solitization. So agent advertisement, what it will do means it will do when the registration exceeds the limited lifetime. So it always has a limited lifetime. So mobile node signals the care of address to the home agent through the foreign agent, and for home agent acts through the acknowledgements through the foreign agent through the mobile network. And these actions, all these things are taken place with respect to security, with respect to authentication. And advertisements, for example, how the advertisements will be done: home agent will advertise the IP address to the mobile network. Okay, home agent will send the advertisement to the mobile network in case of fixed systems. And then the routers, it will adjust with respect to the entries, and if these are stable for a long time, home agent is responsible for a mobile node for transferring the messages over a period of time. Then the packets of mobile networks are sent through the home address. So the home agent, which is independent of changes in respect to care of address and foreign agents, right? So this is the agent advertisement format. So the agent advertisement format from 0 to 7, it is called type, and from 8 to 15 bytes, it is called code, and 16 to 23 and 16 to 31, it is said to be checksum. So what is the type? The type is nothing but when the type value will be 9 and code will be 0. So this will be the extended version, since it has number of address which is to be advertised. So the hash addresses is nothing but number of address which is to be advertised, and lifetime is nothing but time of advertisement, it is to be said to be valid. So how much time period it is said to be valid, the advertisements. Okay, and then these are the router address 1, router address 2, preference level 1 and preference level 2. For example, when we want to check the preference level, so preference level is nothing but it is extension. So the extension is nothing but, so it will have the type to be 16. So when the type is to be 16, how it is length is calculated is 6 plus 4 into hash of COAs stands for care of address. So here we can calculate 6 plus 4 into number of addresses. 6 plus 4 into number of addresses, which calculates the length of the agent advertisement. And then R node is said to be, here R is said to be registration required, and B is said to be busy node when it is more registration, H is said to be home node, F is said to be foreign agent, and M is said to be minimal encapsulation, and G is said to be GRE encapsulation, which is said to be generic routing encapsulation, and R is field which is 0, which is from the for compression, that is Van Jacobson compression, and T is nothing but it is the foreign agent which supports the reverse tunneling, and reserved means the value will be 0 and it is ignored. So this is a registration process based on two scenarios. One is with respect to mobile network to home agent when it has a different foreign agent, and second scenario is a mobile network with home agent within the same foreign agent and within the same care of address. So registration request is given from the mobile network to the foreign agent, and when the registration is accepted, it will send the registration reply as acknowledgement, and when the registration request again is sent to the foreign agent to home agent, and when it is registration is accepted from the home agent, it will send the acknowledgement reply as a registration reply to the home agent to the foreign agent. So this is within the mobile nodes. And when we have a single mobile node and a single foreign agent, the registration request is sent and acknowledgement is taken got from the home agent. These are the two processes of registrations of agent advertisement. And mobile IP registration request, how the registration request will be done. So we have seen in the previous diagram, in the previous frames, here registration request is done. This registration request has a separate frame formats. So this is the frame format for the registration request, starting from 0 to 7 and 8 to 15 and 16 to 23 and 24 to 31. So the 0 to 7 means the type value will be 1, and based on the different values, that is the register, it has different registers. S stands for simultaneous binding, B stands for broadcast datagrams, D stands for decapsulation by mobile network, M stands for minimal encapsulation, G stands for GRE encapsulation, that is R stands for R value is 0 and it is ignored, and T stands for reverse tunneling, which when it is requested it acts, and X stands for 0 when and it is ignored. So here binding stands for data transmission, that is a home agent. Home agent when it is serving the mobile router. When home agent when it is serving a mobile router, binding takes place. Binding is nothing but sending the information from a mobile network to a home agent. When it is sending the request, it is automatically accepting and sending the acknowledgement to the mobile network. This process is called binding. Here we have mobile binding and simultaneous binding. So simultaneous binding in sense, um, it has a flag that is set to be R, and it is automatically set up for forwarding the mobile node. That is said to be the simultaneous binding. in simultaneous binding and normal binding. The difference between normal binding and simultaneous binding in sense, the mobile routing flag R value will be there. This R value will be set with respect to forwarding the data packets to the mobile node. And then we have the unlicensed mobile agent, which is said to be the GRE encapsulation. GRE stands for generic routing encapsulation, right? And we no need of the X and remaining values. So X is said to be 0, which is ignored, right? And this is the mobile IP registration reply. So after getting the request, it will reply. So this reply is set with respect to acknowledgement. So the reply has the packet frame format, which is from 0 to 7, type value is 3, and 8 to 15 code value, 16 to 31 corresponds a lifetime. So 8 to 0 to 7, when the registration is successful, the code 1 means registration accepted, 2 stands for registration accepted but simultaneous mobility bindings unsupported. 65 stands for administratively prohibited, and 66 stands for insufficient resources. 67 stands for mobile node failed authentication. 68 stands for home agent failed authentication. 69 stands for requested lifetime, which is too long, and registration denied by the home agent. 129 is administratively prohibited, and 131 stands for mobile node failed authentication. 133 is nothing but registration identification mismatch, and 135 which has a too many amount of mobility bindings, simultaneous bindings. So next is a process called tunneling. So tunneling, I have already told you, tunneling is nothing but sending the data packets and by from the network layer, from one network to another mobile network. So how this tunneling process takes place with respect to endpoints of the tunnel, which is said to be encapsulator, and from the receiver part, it is said to be the decapsulator. So from the source, it will send the packets to the encapsulator and then to the decapsulator with respect to foreign agent, and which receives with respect to the destination. The mobile node is attached with respect to the foreign network, and the need of tunneling is to deliver the packets addressed to the mobile node to agent that can deliver the datagrams to mobile node at current location. So at current, since it is moving, we need to track of the location. So the datagrams are sent over the tunnel, and multiple SRCs which will receive the destination paths can share the same tunnel. So next is a concept which explains the tunneling and encapsulation. So tunneling is nothing but from home agent to foreign agent. The IP host will be sending the IP protocol frames. So the IP protocol packet frames which will be tunneled with respect to a home agent to foreign agent with respect to IP tunnel, and then it is delivery of data from the mobile node to a care of address with respect to permanent home address, which is with respect to HEA, and which is performed with respect to a concept called triangular routing. So triangular routing, in sense, it is said to be the simplest form that has all packets to the home network, which is sent to the mobile network through a tunnel. So here we can say that we have different home packets, home network packets. All these packets will be sent via the mobile network with respect to a tunnel, right? So inefficient behavior of a non-optimized mobile IP is said to be what? Triangular routing. So we go for the triangular routing for exchanging the data packets from home address, that is from home network, through mobile network through the tunnel. So next is a process which is said to be encapsulation. So with respect to this encapsulation, we can say that whenever the data is transmitted via the broadcast beacon formats, so it will advertise the presence with respect to foreign agent and home agent using the special advertisement message. So the special advertisement message is done with respect to the ICMP, which is Internet Control Message Protocol. So this will be responsible for the packet transfer with respect to one packet into another packet, which is with respect to payload called encapsulation. So the encapsulation taken place, example, with respect to IP version 6 in IPv4 and multicast in unicast, and also it is done in IP with respect to encapsulation. So the tunnel between the home address and care of address. So here the original IP header with respect to original data, and it is having a new IP header with respect to new data, and it is having outer header and inner header and original data. This is the frame format of the encapsulation. So we have encapsulation 1, encapsulation 2, right? So in encapsulation 1, what we are going to learn is that encapsulation of one packet into the another packet, which is with respect to the payload. So here it is considered as IPv4 in IPv6 and multicast in unicast. IPv4 in V6 is said to be 6 bone, and IP multicast in unicast is said to be M bone. So that is, here we have different frames. We need to remember these frames. TTL stands for time to live. So the time to live TTL value, when it is set to be 1, we can say that amount of time a packet exists inside the network with respect to a time period of 1, right? And we have different protocols with respect to IP in IP checksum, and data transfer, and IP address of the correspondent node, and IP address of the mobile node. Here we followed by the TCP and UDP payload. Next is the encapsulation 2, which uses a minimal encapsulation, which is optional. So here in the minimal encapsulation avoids the repetition of the identical fields. So here we have the different identical fields, so which should not be repeated again and again. So hence we go for the encapsulation 2 by sending the TTL value to be 1. So when TTL value is 1, what happens is it automatically sends the ICMP packets with respect to IP, which sends to the destination address with respect to address called 224.0.1, which provides the mobile extension, and send through the broadcast the value of the address to be 255.255.255.0. So this is sent through the ICMP packets to the destination. So this is another routing called GRE, which is the generic routing encapsulation. So you, in this generic routing encapsulation, we have the different packet formats. So in this, we go for the TCP/IP communication protocol, which is used to transport the data, voice, and video packets over the internet, which is also supported by Internet Engineering Task Force. So over which the data packets are sent from the source to destination. This also provides the few further enhancement of IPv6 with respect to wireless networks. The scope is improved with respect to the different framework which is used for multicast traffic. So optimization, how this is done by means of triangular routing. So this triangular routing is a problem. Here it sends all packets via the home network to the mobile network, and with a higher latency and network load. And solutions is that sender sends the current location of mobile node, and using the direct tunneling of this location, the home agent informs the sender about the location of the mobile node. And here the challenge is the big security problem. So how to overcome the security problem? By means of using the advanced encryption standard, AES algorithm. And here it uses a foreign advertisement agent, which is with respect to the change of the foreign address. So how this change of foreign address takes place is that by means of sending packets which change with respect to the host. That is, each and every time the new packets arising from the new foreign agent, which informs the old foreign agent about the packet loss. And old foreign agent, what it will do means it will forward the remaining packets to the new foreign agent, and hence this also enables the old foreign agent to release the resources for the new mobile network. So this is the process, whatever I have explained. First, correspondent node send the data to the home address, and from the home address, it will send the data to the foreign agent, which is old foreign agent, and the old foreign agent will send the data to the new foreign agent with respect to the mobile name. When there is an update, what happens is it will automatically sends the update, and it will automatically register for the new location. So when it is updated, it will send the acknowledgement message as updated, and the data will be sent when the data is having that is, when the data is change of a foreign agent, what happens is it will send a warning message, and after that the request will be taken place, and once it is request is accepted, it will send an update message with respect to acknowledgement. So this process overview is a reverse channeling. So from the reverse channeling, in sense, we can say that from the mobile network to the correspondent node. Already I have explained this. From the mobile network, it will send to the foreign agent, and the foreign agent tunnels the packets to the home agent by encapsulation process, And through the encapsulation process, the home network will send to the correspondent node to and do the encapsulation process, and then it will forward the home agent packets to the receiver. So this all process can be addressed with respect to reverse channeling. And we cannot say that router often it will accept the topological current address, TCA. So this is very difficult. For that we go for the reverse channeling, which does not solve the problems with firewalls. And reverse channel can be abused with respect to another hacking, which is said to be tunnel hijacking. So here in the tunnel hijacking, it takes a double triangle routing method. So in a single triangle routing method, we fail by addressing the problems with firewalls, and then it will have multicast and time to live problems. All these things are solved with respect to double triangular routing. And this is the mobile IP and IPv6. So in mobile IP and IPv6, we go for IPv6, which simplifies the protocol. And here the care of address can be assigned automatically. And through dynamic host configuration protocol V6, we can do the overall node delivery transfer process. Every node has address with respect to auto configuration. So all routers need to perform routing advertisement instead of special routing advertisement. In the previously we do the special routing advertisement, but here it will do the performer has to do the routing operation with instead of using any case of special addressing and advertisements. All the addresses are always co-located. Here the mobile network can send a signal directly through the care of address through home agent, not case automatically part optimization. So here we lose the data packets, which is with respect to handover. The handover process also takes place. It should not do without packet loss. We are going to support for the IPv6. So how it is supported in sense, mobile node sends a new correspondent address to its old router, and the old router, what happens is it will encapsulate all the new packets for the mobile network and then forward send to a new care of address, and authentication is always granted. So this is very important. IP version 6 of the mobile network. Thank you for your patient listening.